In this video, we will look at 5 problems from the first problem set of Physics 170. So the first question has someone running around the blocks. So you're given that each of these length is 400 meters and you're asked to find the total displacement. So remember, displacement is determined by basically 2 points only. One is the initial point, okay, that's where you were in the beginning, and the other one is the final point, which is here. So the displacement is basically the arrow that points all the way from your initial position to your final position. Okay, so from the picture, the displacement vector is represented by this blue arrow here, so it's the S vector, the displacement vector. So displacement in terms of its magnitude is basically just 400 plus 400, so therefore the answer is just 800 meters. Okay, so the second question have Superman, flying down a building at a 30 degrees angle, and you're told he has flown an overall 130 meters. So you're asked to write down his x and y coordinates. Okay, so to do this problem, first you need to identify a right angle triangle. So in our case, this is a right angle triangle that we want to look at. So the x coordinate is basically the length of this horizontal side of the triangle, and the y coordinate is basically the vertical length that you see right here. Okay, so therefore the horizontal length is 130 meters times cosine 30 degrees. Okay, so the vertical length here is 130 times sine 30 degrees. Okay, however, there's a slight complication, which is that Superman is flying down instead of up. So here, if I want to be very precise, I should have added a minus sign in front of it. So if you put in the numbers, basically you'll find that the answer for x is going to come out to be 112.6 meters, whereas the vertical length is going to be minus 65 meters. Again, minus sign came from here. Okay, so for question 3, I only do one of the case. So you have these two vectors. So it partly asks you to find the magnitude and the angles of a minus 2b. Okay, so the strategy of us trying to solve this problem is going to be first figure out what a and what b are. So once you know what they are, then you can calculate any combination of these vectors. So in our case, we want to figure out a minus 2b. Once you figure that out, then you can identify, for example, the magnitude of this, and you can figure out the angle also. So that's going to be our strategy. So let's start with vector A. Okay, so we want to write it down in component form. So you do that, you do what we did before. By now you know we want to find right angle triangle. So if I we draw it up here, okay, so the angle is 30 and the length is 3, so therefore the vertical length is 3 sine 30 degrees. Okay, so that comes out to be 1.5. Okay, so the horizontal distance that you see here is 3 cosine 30 degrees, which comes out to be about 2.6. So therefore the vector that you see here is the horizontal length times I plus the vertical length 1.5 j. Okay, so after you're done with A, then we go back to look at B. So B is just going vertically, so actually in this case you don't even need to draw a picture. So B has a magnitude of 3 meters and it's going vertically up. If something is going vertically up, it means it has to be some numbers times j. Okay, shouldn't have any I components because you're not moving to the right nor to the left. So in this case, B is just 3j. Okay, so once you have that, we have finished the first step in our strategy. So next you want to identify a minus 2b, so you can write them side by side. So let me do it here. 2.6i plus 1.5j, so that's A. So instead of writing B here, I'm gonna do one more step. Since I'm subtracting 2b from A, I'm gonna take B and multiply by 2, okay? So B has no I component, just to be clear. I write 0i, and I have the j component of 6j, because 2 times 3 gives me 6. So now I want to subtract them, so therefore A minus 2b vector is 2.6 minus 0 is 2.6i, 1.5 minus 6 is negative 4.5j. Okay, so now we get this vector, then we can calculate its magnitude and we can find its angle. Okay, so the magnitude is easy to find. You just use the formula 2.6 squared plus 4.5 squared. Put it in your calculator. It should come out to about 5.2. As for the angle, you need to think a little bit. So the first thing you want to do is to draw a picture. Okay, so it's let me use a red pen. So it should go something like this. Okay, so it's 2.6 steps to the right and then minus 4.5j. Okay, so we do what we always did. We identify a triangle. Okay, so this triangle has a length of 2.6 on one side, 4.5 on the other side. So you can call this angle alpha. Okay, so tangent alpha is obviously 4.5 over 2.6. So if you use your calculator, that actually tells you that alpha is 60 degrees. Okay, if you have seen our earlier videos, you know we're not done yet, because alpha is not necessarily the angle theta that we are looking for. In this case, actually the angle that we want is the angle that we can counterclockwise all the way from the positive x-axis to the vector. So we know this is 60. So what exactly is theta that we see in this diagram? So one thing you can see from the picture is that if I walk theta and then walk alpha, then I come back to the same place. So therefore, you see that theta plus alpha gives you 360 degrees. Okay, so what that tells you is that theta is simply 360 minus alpha, which is 60 degrees. So therefore, the angle of the vector to a minus 2b actually is 300 degrees. Okay, so that's question 3D. So all the other questions can be, all the other questions in question 3 can be done similarly. In fact, most of the questions in this problem set can be solved in the following manner. So later I'll skip a lot of the questions because they are basically a repeat of what we are doing in this problem.